Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, where the screen is visible or not, right? Yes. So in that Hadoop providing two services is meant for storage. There is one processing, both it can perform. For storage, we are using a file system called Hadoop distributed file system. And for processing, we are using MapReduce or Spark. Currently, we are going with Spark. And clearly understand that Hadoop is not for online applications. It is only for batch applications. There are two types of applications, online and batch applications. Hadoop is for batch applications, not for online. Means here user interactive applications, we say right, online applications and batch applications, right? User non-interactive applications, we call them as batch application. The user is nowhere required. Railway ticketing, PNR status, right? The state currently the waiting stated, if we say like 200, after 1 hour it is 150, tomorrow morning like 70, tomorrow evening it got confirmed. Everything happens in the background, right? User is nowhere required. And generating credit card statements for millions of customers. User interactive applications here, here booking a movie ticket, making an online payment. Here user has to give the input, the source and the destination, right? But batch applications, most of these Hadoop applications are batch applications. Means most of these banking and financial applications are batch. Drawbacks with the current databases, most of the databases limited storage, no parallel processing in most of the databases, right? Limited storage and no parallel processing. If volume is increasing, the speed decreases in the case of Hadoop, right? So if we talk about the total amount from sales one, total amount from sales two, total amount from sales three. If we talk about the table consisting of 10 records, 1 lakh records, 1 crore records, total amount from 10 records, total amount from 1 lakh records, total amount from 1 crore records. So this record to record, we talk about this, right? Means if you talk about this query to query, as the volume increasing, the speed decreasing, right? This first query take more time, sorry, it will take less time, and as compared with the remaining, right? Even if complexity increases, the speed decreases. Talk about the total amount or average amount or standard deviation of amount, right? This average amount takes more time as compared to the first query, right? Because here first sum to be calculated, next average to be compared to the standard deviation, right? Lot of internal processing required. So this query to query, as this complexity increases, the speed decreasing, and also like the databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Yes. Hadoop doesn't follow client server architecture. I was saying, right? Hadoop doesn't follow. It's not for a request. Whenever you give a request, it's giving a response. It's not getting response. It is for master slave architecture. Single master, multiple slaves, like single master and multiple slave, right? Yes. The single master and multiple slaves. Hadoop follows master and slave architecture. This we call it like slave nodes. S1, S2, so on up to Sn. This we call it like master node. Master node. In Hadoop terminology, right? And within this, we have got a name node. Name node. This we call it like slave nodes or data nodes. Data nodes, right? So data is stored within the slaves. Data is stored within the slaves, and data is processed by the slaves. Data is stored by the slaves and data is processed by the slaves, right? Yes. Yes. So here in Hadoop, data is stored in the form of files, f1.txt, like files in databases tables, but here in Hadoop, in the form of files. The file is subdivided into smaller parts. The file is divided into smaller parts that each part is going to be stored across one system. So here two advantages you are seeing, right? Distributed storage and parallel processing. Distributed storage and parallel processing. That's why we see very high speed for Hadoop, right? So there are two types of node, master and slave node. Master node responsibility, assigning the task to the slave, balancing the load equally to all the slaves. If any slave goes down, if it is faced, if any slave fails down, task of that slave has to be provided to any of the other slave, right? Health monitoring, right? Health before assigning the task to the slave. Before assigning the task to the slave, master node will have the health status of each and every slave. Okay. Slave node responsibilities. Two, storing the data and processing the data. Stores the slave node, stores the data, etc. Slave nodes stores the data and slave nodes are going to process the data, storing data and processing data, right? Hadoop advantages, right? Unlimited data storage, unlimited data storage because of a feature, horizontally unlimited scalability, horizontally unlimited number of slaves can be added, very high speed processing because of this parallel processing, as data is distributed across multiple slaves. As data is distributed across multiple slaves, they are processed by multiple slaves parallelly. Can handle all varieties of data, structured, semi-structured, and unstructured. It's an open source, no licensing required. It's a commodity hardware. On any hardware it can run. Doesn't mean that you need to have highly configured systems for Hadoop, right? So Hadoop advantages, unlimited data storage, very high speed processing, can handle all varieties of data, open source. Why databases like Oracle? Why databases like Oracle won't support unlimited storage? Right. Databases also can have multiple slaves or multiple nodes or CPUs, right? But there is a limit for that on the number of nodes. Talk about this Oracle has got up to 256 nodes. MySQL has got 54. MySQL Express has got 256 nodes. SQL Server has got 256. Can support DB2 can support up to 256. Means all these databases, right, can support up to 256. Beyond that, they cannot support. Teradata, currently it is supporting 1024 CPUs or nodes. Netija also, right? These are used for data warehouse purposes, right? Teradata, Netija, Vertica. These are specialized databases used for data warehouse purpose, right? They can store up to 1024, means they can support up to 1024 nodes. But there is no limit on the number of nodes that Hadoop can have, right? There is no limit on the number of nodes that Hadoop can have. It can go with unlimited number of, slaves. When Yahoo first time implemented Hadoop, it went time implemented Hadoop, right, went with 4,000 nodes for storing its data. Currently, it is using 12,000 nodes for storing its data. When Facebook first time implemented Hadoop went with 8,000 nodes. Currently, it is going with 42,000 nodes. So Hadoop is proven storage point of view and processing point of view, like with unlimited storage and processing point of view also, right? Yahoo test it has performed a test, right? Yahoo has performed a test to check the speed of different databases, different data. It has taken a table of size 100 TB consisting of 1024 columns, sorting based on 16 columns. The task was sorting based on 16 columns. Oracle has taken nearly 3.5 days to process it. MySQL has taken 6 days to process. Teradata, a specialized database used for data warehouse, taken 4.5 hours. Netija has taken 3 hours. Hadoop, finally Hadoop, right? It has just taken 3.4 minutes. The latest version of Hadoop, like 1.2 minutes. Right? So as discussed, right? So we have got some storage components for and processing components for processing, right? So this was Apache Spark. I was giving this, like I was discussing about this Apache Spark, why PySpark, need for PySpark, right? So just an introduction on this. Uh, Distributed cluster computing, right? With distributed cluster computing, right? Introduced by Apache, right? The general engine for Apache. It's for data analysis, data processing, and computation. So why PySpark is it's a Python API for using Spark. It's an open source cluster computing, right? Used for big data solution. It's lightning fast technology for design for fast computation. One of the demanding tool about that among the data engineers to work with the bigger data sets. Need for this PySpark, right? So it is used for running a distributed SQL, for creating data pipelines, for ingesting data, right? Running ML algorithms, working with graph algorithms, running data streams for streaming, right? And real life usage of PySpark. Okay, and if we talk about this, so the huge data which is containing like some hidden patterns, unknown corrections, customer preferences. So we need to extract some uh, important information from this raw data, right? So we require some efficient tools for performing these type of operations on huge data. So for that, we require some efficient tool and scalable tool to crack big data and gaining benefit from it. So PySpark is one of such kind, right? Yes, PySpark is one such a kind. And real life use cases, right? It is used in this commercial sector, right? For real-time processing and for banks and financial systems and retrieving the social media profiles of different customers to help in taking the right decisions, and in fraud detections in entertainment industry, right? Like Netflix using PySpark for this personalized web series and movies and processing nearly 450 billion events per day. And even for e-commerce like Flipkart, Amazon, all this, they are using Spark, right? For advertising. Yes. So because of this very high speed processing, there is a huge demand today, like for the PySpark developers with huge bigger packages, right? So ecosystem components. So one storage component I'll be discussing, and MapReduce execution model. It's one of the processing execution. Apache here is one of the important component of Hadoop. Even there are jobs available only on Apache Hive. If you have got a good command on this Hive HQL, like similar to SQL, we have got HQL here. Say processing component for meant for data warehouse purpose. We have high query language, which is almost similar to SQL. And Scoop for SQL plus Hadoop, right? SQOOP, the first two characters of this and last three characters of this. First two characters and last three characters forms a scoop. It is also meant for import or export operations. NoSQL databases. One NoSQL database I'll be discussing, right? It has got schemaless behavior and for random access. Also like the NoSQL database like HBase I'll be discussing. Yarn, yet another resource negotiator, right? Yarn. Yeah. So what are the yarn components, how the yarn processing is going to happen? And this zookeeper controls and coordinates these Hadoop components, right? And I also provide you knowledge on this streaming data and technologies, right? Yes. Okay. Flume Kafka, right? And PySpark. Mostly my concentration will be on PySpark, Spark Code, Spark SQL, Spark Machine Learning Library, and Spark Streaming, right? Yes. How exactly, how exactly the data storage, how exactly the data storage and processing, right? How exactly the data storage and processing in Hadoop. How exactly the data storage and processing in Hadoop. In Hadoop, data is stored, right? In the form of files. Data in Hadoop, data is stored in the form of files. In the case of databases, it is stored in the form of tables. Data is stored in the form of files. Each file again subdivided. Each file is again each file again is again subdivided into blocks. What is that block size, right? Each file is again subdivided into blocks. Default block size. Default block size, right? It's 64 MB. Means what is the size of each block? Default block size 64 MB. In latest version, it is 128 MB, right? Default block size is 64 MB. In latest version, it is 128 MB, right? For example, if I got a file f1.txt, assume you got a file f1.txt, okay. How exactly the data storage and processing is going to happen, right? So observe this. I got a file. Assume I got a file f1.txt. The size of this file 200 MB. Into how many blocks? Into how many blocks? Number of blocks. Number of default block size. Observe this default block size. You have set to 64 MB. By default, the file is divided into blocks. Each block size 64 MB. Number of blocks. File size by default block size. File size is 200. 200 by 64. 200 by 64. 200 by 64 means nearly 4 blocks. Four blocks means B1. Then think that f1.txt is a data like banking data. Banking data. So for default block size 64 MB, number of blocks, file size 200 by 64, like 64, 64, 64, like, so 4 blocks. 4 blocks, right? Yes. This is 1, 2, 3, 4. B1, B2, B3, B4. B1 of 64 MB, B2 64 MB, B3 64 MB. This is only 8 MB, right? Only 8 MB is filled. Out of the 64 MB, 8 MB only is filled. 56 MB free here. Okay. A file on Hadoop, always the file is divided into blocks. Default block says you can set as anything 64, 128, or any of yours, whatever the size. f2.txt, right? This is a telecom data. You got some telecom data in this. The size of this is 192 MB. The size of this is 192 MB. Into how many blocks? Into how many blocks, right? 192 by 64. 192 by 64. 3 blocks. 3 blocks, right? B1, okay, this is B5, B6, B7. B5, this is 64, this 64, this 64. Here, a query, right? 56 MB is free here. 56 MB is free here. Why B5 data not stored in B4? Why the B5 data is not stored in B4? Question, right? 56 MB free in B4. Why B5 data is not stored in B4, is not stored in B4? Why B5 data is not stored in B4? Why B5 data is not stored in B4? Means assume I want to retrieve, for example, retrieving f1.txt. Retrieving f1.txt means B1 plus B2 plus B3 plus B4. I need to retrieve these 4 blocks, right? Retrieving f1.txt. If I want to retrieve this f1.txt, means that I need to add all these blocks, B1, B2, B3, B4. Assume if B5 stored in B4, if B5 stored in B4, if B5 data stored in B4, 64 plus 64 plus 64 plus 8 plus 56 MB of B5 means totally you will get 256 MB. Whenever you're retrieving f1.txt, right? 256, but actual file size is 200 MB only, right? But actual file size is 200 MB. Means this is wrong computation. Means whenever you are trying to retrieve f1.txt, that is banking data, you are getting 56 MB extra data of telecom data. So every file should have its own number of blocks. In a single block, no two files data has to be stored in a single block. So every file will have dedicated number of blocks, right? So here I write design principles, right? With respect to HDFS blocks. Design principles with respect to HDFS blocks, right? First one. Every file should have dedicated number of blocks. Every file should have dedicated number of blocks. In a single block, no two files data. Every file should have dedicated number of blocks. In a single block, no two files data to be stored. In a single block, no two files data to be stored. Every block will have equal volumes. Every block will have equal volumes except the last block. Okay, understood, right? Every block will have equal volumes except the last block. Understand here? This last block will have only 8 MB, remaining all will have equal values. In a single block like before, no two files data to be stored. Every file should have dedicated number of blocks, right? This is the design principles with respect to HDFS blocks. We can also configure the block size, increase or decrease. We can also configure, right? We can also configure. Configuring means increase or decrease. Increase or decrease. We can also configure increase or decrease the block size. We can also configure, right, increase or decrease the block size. Okay, for that, go to the Hadoop installed folder. Go to the Hadoop installed folder, right? Go to the Hadoop installed folder, means within this Hadoop, right? Within this etc folder, within that we see like conf folder, configuration folder. Within that we see like hdfs-site.xml. We'll see one file with this name, right? It will be an empty file, hdfs-site.xml. If you go to the Hadoop installed folder, in this conf folder, you will see this file hdfs-site.xml. It will be an empty file. Just we need to write the following configuration. XML means we can create our own tags. For example, configuration. So here, hdfs-site.xml, and write the following configuration. Configuration, right? Yes. Configuration. Within this configuration, one property we need to set. Property, right? Opening and closing tag for it. Opening and closing, right? Slash property, yes. Within this property, the name of the property is property name. Name of the property, right? DFS, distributed file system, like block.size. DFS dot distributed file system dot blocks dot size. DFS dot blocks dot size. Value. What is the block size? Distributed file system dot blocks dot size. It is 64 or 128. Even you can set like 50 MB, 50 or 100 MB or 50 MB or 150 or whatever it is, right? Slash value, right? Yes. Okay, that's it. Property, one property. What is the name? Distributed file system dot blocks dot size. What is the size? 50 MB. 50 MB, right? Yes. Which one? Okay. Now, so I'm going to discuss some cases here. 3 cases I'll be discussing. Just understand here, right? Case 1. Consider this case 1. If the number of blocks, otherwise, number of blocks equal to number of slaves. Number of blocks equal to number of slaves. Four blocks, S1, S2, S3, S4. Four blocks are there. Assume you got 4 slaves. If number of blocks equal to number of slaves, more parallelism. More parallelism, right? More speed. Number of blocks equal to number of slaves, more parallelism, more speed, you see, right? For example, f1 dot txt. See, default block size. Assume this default block size. Just understand how exactly the storage and processing is going to happen. In this example, you'll understand, right? Default block size 6. F1.txt 230 MB, right? Default block size, assume it is 64 MB. Default block size 64 MB. Into how many blocks? Number of blocks. 230 by 64. 230 by 64, right? 4 blocks. How these 4 blocks, right? 4 blocks means B1, B2, B3, B4. And always in Hadoop, the file divides into blocks. How these blocks are going to be stored across these slaves? Master slave, right? Single master and multiple slaves. System 1, System 2, System 4. B1 stored here, B2 here, B3 here, B4. B1, B2, B3, B4. This is master. These are slaves. Master and slave, right? Yes. F1 dot txt. F1 dot txt into how many blocks? B1, B2, B3, B4. B1 in S1, B2 in S2, B3 in S3, B4 in S4. See, 4 blocks stored across 4 slaves, right? See how exactly the storage is happening, right? File divided into blocks depending upon the default block size. The blocks, 4 blocks stored across 4 slaves. Okay. Now, data processing, right? Data processing. The job to process f1.txt, job to process f1.txt, always into number of tasks. always into number of tasks. Into tasks. How many tasks? Number of tasks equal to number of unique blocks. Number of unique blocks. Number of tasks is always equal to number of unique blocks. How many unique blocks? 4 blocks. Number of tasks always in number of unique blocks, 4. Means 4 tasks. T1, T2, T3, T4. T1, T2, T3, and T4. Okay, job to process F1 dot txt into how many tasks? 4 tasks. T1, T2, T3, T4. T1 for executing. T1 for executing. B1. Think that in B1 10 lakh records, in B2 10 lakh records, in B3 10 lakh, in B4 10 lakh. 10 lakh, 10 lakh, 10 lakh, 10 lakh. 10 lakhs, 10 lakhs, 10 lakhs, 10 lakh records. T1 for executing B1 10 lakh records. T2 for executing B2 10 lakh records. T3 for executing B3 10 lakh records. T4 for executing B4 10 lakh records. Okay. Who should execute this T1 task? Who should execute this T1 task? Which system? Means T1 is for executing B1. B1 is present in system 1. Executed by system 1. This executed by system 2. By system 3. By system 4. Slave 4. Means B1 present in S1. So S1 only should execute. So B1 10 lakh, B2 10 lakh, B3 10 lakh, B4 10 lakh. B1 is present in system 1, so system 1 only can execute. B2 stored in slave 2, system 2, then B2 by S2, B3 by S3, B4 by S4. 4 blocks are stored in 4 systems. Means executing this B1 is nothing but T1 task. This T1 task assigned to S1, T2 task to S2, T3 task to S3, T4 task to S4. 4 tasks are assigned to 4 slaves. 4 tasks here, 4 tasks T1, T2, T3, T4. Here 4 tasks are executed by 4 slaves. Here 4 tasks are executed by 4 slaves. S2, S3, S4. Here 4 tasks are executed by 4 slaves parallelly. 4 tasks are executed by 4 slaves parallelly. High speed, you can see high speed. None of the task is in the high speed, you see, right? None of the task is in the waiting state. None of this task is in the waiting state, right? So that's why more parallelism, more speed you can see in this case one, right? If the number of blocks equal to number of slaves, that is case one. Observe this case two here. Okay, file, new file. Observe this case two. Observe this case two, right? Number of blocks greater than number of slaves. Assume you got 4 blocks, you got 2 slaves. 4 blocks like B1, B2, B3, B4, 4 blocks, but 2 slaves, only S1 and S2. So think that you got a file f1.txt. The size is like 230 MB. Number of blocks into how many blocks? Assume the default block size. Default block size equal to 230 by 64. So default block size 64 MB. 230 by 64 means how much? 230 by 64. How these 4 blocks are stored across 2 slaves? Only 2 slaves, right? Single master and multiple slaves. Single master and multiple slaves. S1, S2. So here, this is master, this is master, these are the slaves. Master node. Within that, we've got a name node. Name node maintains the metadata information. Name node maintains the metadata means data about data. It won't store that actual data. Actual data stored within the slaves. Name node stores the metadata, data about data. Data about data. So how these 4 blocks are going to store in the 2 slaves? B1 here, B2 here, B3 here, B4 here. B1, B2, B3, B4, right? B1, B2, B3, B4. Right. 4 blocks across these 2 slaves. 4 blocks across these 2 slaves, right? Yes. Okay. Now this is how this observe this f1.txt into 4 blocks. It is divided B1, B2, B3, B4. B1 by S1, B2 by S2, B3 by S1, B4, B1 by S1, B2 by S2, B3 by S1, B4 by S2, right? Yes. Okay. Yes. His slave is not fixed here. For example, I'm talking right here. If you got some, here I've taken a small file size, so that's why you can see 4 blocks. Then that you have got 400 blocks. Means, for example, you got 80 blocks, but only 40 slaves. That means blocks are more, slaves are less. Means what? 80 blocks, but only 40 slaves. How? Means in each slave, two blocks are stored. I'm talking about. Means here blocks are more, slaves are less. Means less speed you are going to see. You less speed you will achieve, not like in the case when we see high speed, but here less speed, because some tasks will be in the waiting state here. In case when no tasks are in the waiting state, but here some tasks will be in the waiting state. Job processing, job processing, job to process f1.txt, job to process f1.txt. Always in Hadoop, number of tasks always depends on number of unique blocks. Always the number of tasks equal to number of unique blocks. Number of tasks always depends on the number of unique blocks. How many blocks? How many blocks? 4 blocks. 4 blocks means 4 tasks. So T1, T2, T3, T4. T1, T2, T3, T4. T1, T2, T3, T4. Right? Yes. Job to process f1.txt. Job is to process f1.txt. The job is divided into 4 tasks: T1, T2, T3, T4. T1 for executing B1, for executing T2 for executing B2, T3 for executing B3, T4 for executing B4. Who should execute this T1 task? Yes. Where this B1 is present? S1. S1 only should execute. T2, okay, who should execute this T2 task? Who should execute this T2 task? F. You can unmute yourself and you can give your responses, right? I want the sessions to be interactive. Yes, otherwise in the chat you can give responses, right? Yes, already some are providing. Yes. Who should execute this T2 task? S2. Who should execute this T3? T3 means for B3, right? B3 present in S1. S1 only should execute. T4 by S2. So here observe. You've got two slaves, S1, S2. S1 executing two tasks, which are the T1 and T3. S2 executes two tasks, T2 and T4. Observe here, right? When T1 is executing here in S1, T1 is executing, T3 will be in the waiting state, right? When T2 is executing here in system 2, T4 will be in the waiting state. T4 will be in the waiting state, means only T1 and T2 are executed. When T1 is executing, T2 is executing, right? T3 and T4 will be in the wait. One T1, T2 execution completed, then T3, T4 will be executed. Think that you got 80 tasks. 40 slaves. Means 40 tasks will be executed parallelly, but 40 will be in the waiting state. 40 tasks will be in the waiting state, right? Means that's why less speed. Means here, first this T1, T2 executes. Once their execution completed, T3, T4 would, right? So double the time it takes, like the step as compared with the case one, that double the time, more time it takes. Now, if you go to this case 3, if you observe this case 3 here, right? 1 second. More blocks, but only one slave. Blocks are more, but only one slave. More blocks, but only one slave, right? 4 blocks, one slave. B1, B2, B3, B4. 4 blocks, but only one slave, S1. Assume. F1.txt, 230 MB. Number of blocks. Number of blocks, how many? 230 by 64 means 4 blocks. How these 4 blocks are stored? How these 4 blocks are stored, right? How these 4 blocks are stored across, right? Yes. 4 blocks. This single master, only single slave. B1, B2, B3, B4. This S1. Master, this is slave. Master slave, right? Single master, multiple slave. Only one slave. Means here f1.txt divided into 4 blocks. B1, B2, B3, B4. B1 by S1, B2 also stored by S1, B3 also by S1, B4 also by S1. Data processing, right? The always job is divided into tasks. In Hadoop, always the job will be divided into tasks. Number of tasks equal to number of unique blocks. I am saying the word unique. I'm saying the word unique, right? Number of unique blocks. How many unique blocks? How many unique blocks? 4. Means 4 tasks. T1, T2, T3, T4. All these 4 tasks should be executed by system 1 sequentially. Sequentially, one after the another. Means it is going to take more time. In case 1, if I take labor example, right? Each task take 1 hour. Each task take 1 hour. So here 4 tasks, 4 slaves. Total time taken, total time 1 hour. For executing all the 4 tasks, if you have got 4 slaves, total time taken is 1 hour. 1 hour, right? In case 2, 4 tasks are 2 slaves. 2 tasks by S1, 2 tasks by S2. Time taken Time taken is 2 hours because for first two tasks it takes 1 hour. Second two tasks it takes 1 hour. Was only two slaves. Case three, case three, four tasks, but only one slave. Only one slave. Time taken 4 hours. So here 1 hour, it is 2 hours. Here it has 4 hours. Means if more slaves, more speed. Less slaves, less speed. Only one slave, no parallel processing at all, right? So that's why. So understood this case right? How exactly the data storage and processing is happening in this, right? So I'll provide the clear notes for this. I'll provide the clear notes for this all, but try to understand how this storage and processing is happening in this Hadoop environment, right? This everything, see the storage, everything we are not going to take automatically taken care by the Hadoop framework. It automatically divides the file into blocks. We only need to specify the block size. Automatically the file gets divided into blocks stored across these multiple slaves. Right? And here I've got one query here. If four tasks are executed by four slaves parallelly, if any one slave goes down, as they are machines, right? If any one slave goes down, then you can see this B2 block, B2 data is lost, B2 block data is lost. Okay, this T2 task will be failed. The T2 task will be failed, right? Okay, fine. Okay, fine. Understood, right? So here, if that particular system is down, two things we observe. B2 has got 10 lakh records, 10 lakh records will be lost, and this T2 task will be failed. T2 task failed means job also failed. So how Hadoop is able to overcome this kind of situation means has got the concept of replication and fault tolerance. Has got the concept of replication and fault tolerance, right? What is the replication fault tolerance I'll be discussing, right? Understood everyone? If a task and this there won't be any data loss, there won't be any task failure. They have got concept of replication and fault tolerance. Yes. Okay. Understood. Any queries in this three cases, anyone? Right. How exactly the data storage is processing is going to happen, right? That next in the next session, right? I'm going to discuss about two things. Replication and fault tolerance is the one. How this Hadoop is able to overcome these things, right? And second is Hadoop architecture, storage architecture, processing architecture. We have got architecture, storage architecture of Hadoop and processing architecture, right? Yes. So next week we are going to spend some time, more time, right? So I'll be discussing about the replication and fault tolerance and Hadoop architecture, right? Yes. So I'll be providing the software to your Google Drives. Your Google Drive, you will be getting a software, right? Like one RAR file, you will be getting a RAR file, like a zip file, right? It will be of 5 GB, right? Try to download that 5 GB. You extract it. After extracting, right? Yes, you will get a just extract and keep it. And I'll just demonstrate about it, right? Okay. You will get the software to your Google Drives, software to your Google Drives, notes to your mails, and videos. The every session videos you will be getting to your Google Drive, right? Every like videos you will be getting to this Google Drive. Okay. Next, class notes, clear notes, everything, and yes. Next week, right? I'll just create a WhatsApp group. A WhatsApp group next week. A WhatsApp group is going to be created, and you will be added to the WhatsApp group. If you've got anything, any errors or anything, you can take snap and you can post in that, right? So I want the sessions to be more interactive. Try to have some audio device connected, right? Means where you can speak and you can give response. You can ask queries and respond whether your answer is correct or wrong. I want the sessions to be more interactive, right? Yes. These things, Google Drive, you'll be getting the videos, everything. In this Google Drive, check in your Google Drive. Everyone, if you have got enrolled, right? If you have got enrolled, if you have got paid the fees, right? To your Google Drive, there will be shared with me option will be there. Shared with me, whatever anyone shares, right? You can say share with, in that you can see the videos of this. From this, what all that we have discussed, right? From everything, all the videos you will be seeing here, right? So still, if anybody not enrolled, right? If anyone of you try to get enrolled, right? And next, and one more thing, next Saturday, you will be getting a new link, new Zoom link to your mails, right? Follow that Zoom link up to the end of this course, right? That will be that. Follow that Zoom link up to the end of this course, right? So try to get enrolled. Still, if anyone not enrolled, right? And you'll be getting all this software. You'll be getting notes, clear notes. You'll be getting. So whatever I discussed till now, right? So you can see that how exactly the data storage, design principles, and here case one, whatever that case one I discussed, you can see that notes of that case one. Case two, just now we have seen case one, whatever we discussed in today's session, number of blocks equal to number of slaves, and this entire what is the process. Case two, if the blocks are greater than slaves, and case three, right? Everything, right? So clear notes I'll be forwarding, right, to your mails. Fine. Any queries from your side, anyone, right? Yes. Even Hadoop and PySpark, you can attend parallelly. Hadoop and PySpark, because PySpark I'll be spending a lot of time for it. So both, if you are taking one after the time duration will be long. Hadoop and you will be understanding everything 100% whatever I discussed, right, during the sessions. Any queries, try to ask. I'll provide multiple examples, right? So I will stop for now. We'll continue next Saturday, right? So everything you will be intimated in the mail, right? Everything. If you got anything, you can just uh, uh, tomorrow or day after tomorrow, the online team. So I'll create a WhatsApp group, and the online team will add all of you into the WhatsApp, right? By tomorrow evening, right? You'll be added to the WhatsApp. Yes. So get enrolled and try to the notes you'll be getting. I'll keep that notes in the WhatsApp once you got added. And videos you can check in your Google Drive shared with me option. Software also I'll forward to your Google Drive. Make it ready before we start with the practical part. And WhatsApp will be added tomorrow itself. I'll ask them to create. I'll create and I'll forward that. They'll be adding you into that WhatsApp, right? Fine. So I'll stop for now. We'll continue next Saturday, more discussion on this one. Yes. Fine. So fine.